The point A and D. Other points, all are having same capacitance. And then how to manage this? So the charge distribution, if you go for, so the same charge, okay, plus Q charge will come. So here it will branch out. Q1, Q2, this will be Q1, this will be Q2, will combine, will become Q. Similarly here, it will combine Q1, Q1, Q2, and will get Q. This is 2Q. This is 2Q. So again, what is the circuit? So the charge here, in fact, will not branch. The charge here, in fact, will not branch. This charge will, in fact, will not branch. So remove this. So we can slightly show that the connection, it should be off like this. Now I think we can simplify. These two are in series. These two are in series. The effective is in parallel with this, and that effective is in series with this one. So this will be, if you call this as 1 farad, no, 1 and 1, 1 by 2, 1 by, this will be 1 farad. 1 farad, 1 by 3, 1 by 3, and here 1 by 3. How much it will be? 2 by 3. I think that is what. Okay, this one. So here the condition is something to make you understand. The charge will not branch. In fact, they are connected actually. This path are connected, but charge will not branch. Okay, this is about A. Now he's asking to get AI. Where the cell is connected between A and I. Very good question. You have to fight with the conditions available here. Just making you to learn the charge distribution. Okay, there's option A. We got it. So we'll try for option. So a cell will be connected across A and I. I'll take the same circuit diagram. No. Between A and I is being asked. So where the cell is going to be connected across A and I. So we will not color, contrast color will take it. So this is the way what will be connecting a cell. So bring it this point. Make a jump like this, no connection. Okay, this what the between points A and D connected. So now the charge will enter here. Charge Q will enter. This charge, anything will happen. It will branch out Q1 and Q1. So why equally? Again, you have to look at this particular thing. These two are similar junctions, same capacitance, and also you see that one. The capacitance path will be same. The B, C, D, I. Here also H, G, F, I. So what to do this particular? So what all we have sent a charge, it will flow like this. Will there be any flow of charge across this? No, there won't be flow of charge. So there's no flow of charge, so you can remove that from the circuit. Because the charge will take place. The distribution of charge is very important. So here, charge Q2 let it branch here. Q2 will get into the this one. Here Q3 will come. Here Q3. That Q3. Here Q4, let's assume, and here Q5. Similarly, same thing here. Q4. And this will be Q5. Q5 and Q5. So not possible, no, here. So plus Q5 minus Q. From here plus Q5 will come. From here Q5 and minus from here plus Q5 will come. Will not be conserved. So therefore, no charge should be there in those capacitors. So now how the path, if you take it, these three are in series. And that effective is in parallel with the capacitor connected between I and B. Similarly, these two are in series. And that effect will be parallel across this one. So this will become C by 3. C by 3 in parallel with C will be 4C by 3. So the next part of the circuit will be this can be asked, it's not a big deal. So this everything between H and I. C by 3 will bring it. This is C, this is C, this is C, and the cell is connected here. C by 3, C. These are our points, A and I. Now, how this C by 3 is this C by 3 is parallel to this 4C by 3, it will be. This will be 4C by 3. And 4C by 3 in series with this, the next part of the circuit. The battery symbol will show it here. Not needed. So this is the point A, this is the point I. I think now we can work out. Four C by 3 into, so 4 by 7 plus 4 by 7 will be 8 by 7. We'll get it here. So this AEI, CAI will be 8 by 7 microfarad. Can you, now he's asking to get HI. Then HB also. Try this. Try this. It's a very, very good question. Between HI is asking. So the cell from here, you're going to send a charge. Okay, the charge will divide. So you cannot remove this capacitor. Again, you can see this from H. Okay, one charge will flow here. So other charge should return. Again, this charge will return here. So some part of charge will go there and some part of, I'll solve it. Okay, this is for option B. Option C, H and I. H and B you work out. H and I last one more, I'll tell it. So across H and I will connect a cell. The cell is connected between H and I. Okay, these are points you put it. Just only show the distribution of charge. That will be, with that you can manage. Okay, this will be charge, say Q. So it will branch out here. Q1 and Q2. Similarly, here it will be Q1. This will be Q2. So this charge will be Q3. This will be Q3 and 2Q3 will come here. I think charge should be conserved. What charge? 2Q charge has left. Finally, the 2Q charge has returned. Okay, yes. Q naught, you write it. They'll be okay. So what was the charge that was supplied by the cell? 2Q plus Q naught. The 2Q plus Q naught has returned back. Then so what I can say that is like across H and I. Anything can we put it? Because the distribution of charges are there, no? Earlier it was very easy. We removed some part of circuit that this we did here. With respect to this, can we define equipotential? G and A are at same potential. F and B are at same potential. Similarly, the E and D are at same potential from the circuit available. VG equal to VA, VF equal to VB, VE equal to VC. I'll redraw the circuit. So G, it will be AG, FB, then E comma D. And this is what? High, and this is H, where we have connected a cell. One capacitor there, put it here. This is our cell. Okay, this is our cell. We'll start the problem from here. Okay, this is H and I. So from H2G and H2A, one capacitor is there. Two capacitors, bring it in this way. Between G and F, one capacitor. Between A and B, one capacitor. So here two capacitors. Between F to I, one capacitor. Between B to I, one capacitor. F to E, one capacitor. And F to D, one capacitor. E to I, there is no capacitor there. But D to I, there's a one capacitor there. I think we have B to C. So the C, where is the C? C, I didn't intend it. F, B, C, E, no. Oh, this is some correction. C, E, it should be there. C, E, this is I. Then here D should be there. Okay, now it will be okay. Now, C to D, one capacitor. E to D, one capacitor. Now, okay. Then I to D, one capacitor. Between I and C, there's no capacitor there. So I think now we can put it. So this will be C by 2. C by 2. This will become C. It will be C by 2. So this, I think these two are C by 2, C by 2. This will become C. This will become C by 2 again. C by 2, parallel C by 2 will become C. Will be C by 2. And C by 2. So C by 2, C by 2, C by 4, 5C by 4, 5C by 4 plus C. 9C by 4. Also 9F by 4. not their options. Yeah. Check calculation once. I think first we'll count the capacitors. So 1, 2. Twelve capacitors are there. I think, okay, 2, 4, 6, 8, 10, 12. You can see this now, the CHI. How much I said? Oh, anybody just can you repeat? I said some answer, no? Once again, we have to work out. So this will be C by 2, C by 4, C by 4 plus C, 5C by 4, 5C by 4 plus C, 9C by 4. Check it, am I right? Total effective capacitance. C is 1 farad, no? So 9F by 4, it's not there. Work out the other one. So it took a lot of time. So I'll take the next one. The complete description of problem. This is what we are discussing.